Hello and welcome to the C++ Insights YouTube channel. I'm Andreas Fertig. I work as a C++ trainer offering classes worldwide, on-site or remote. This is my YouTube channel where I use my tool C++ Insights to teach you various topics related to C++. Today I like to do something new. As you might know, I read the comments on my YouTube channel and I occasionally reply to them as well. And today I decided to, instead of leaving just a reply, making out an episode of one of the comments or questions. And what I picked is a comment to episode 51, the magic of C++20's source location. The user here says that they find it interesting, the source location, and question whether they should pass a source location object by value or by const reference. And stating that potentially a source location should be a small object, but due to what's stored internally, might have the size of at least two size t's here to summarize that. If we check CPP reference first, we can see what it's talked about here. The CPP reference also says in this section here that a source location object is intended to have a small size such that it can be copied effectively. If we also want to deep dive into the standard, I'm using the HTML version here. This is source location here in the support library. We will find the exact same note here in note 1 that says that source location should have a small size and efficient copying, but it's unspecified whether copy or move constructors or copy or move assignment operators are trivial and are const expert. So a lot of uncertainty here. Implementers get a lot of implementation freedom, and this is usually to target different architectures. Let's recap maybe first. I will also link you the episode what source location briefly does. So assume that we have a custom assert function here and we want to make our users be able to call them. If we use plain C++, pre-C++20, we have to pass the condition, a bool, a message, a function name, and a line number, requiring from your users to pass all these additional 3 or 2 parameters here that might be a bit too much for them. So usually we wrap that in an assert, and the assert uses the C functions or macros here, underscore function, and a line. And the preprocessor then expands that to the according function name and the line number. Our users then conveniently use the assert macro. The disadvantage here is that we have 2 times the name assert, slightly differently spelled, but the one should be used, the other one should be hidden. So you can come up with a more obfuscated name for the original function, but it's still, users have to know that, and we have a macro in here which has other problematic parts to it. If you're now using source location, then things start looking like this. I still have my regular C++ function assert. It takes the condition as the first parameter, the message the user provides in case the assertion fails, and then as the third parameter, it takes a source location object, and only that, not a function or line number, because source location encapsulates all that. And the special thing here about source location is the static member function current, because this one is capable of fetching the function name and line number on the call side. If we usually use default parameters, they get expanded at the point where the function really is. So you can listen or see more about current in episode 51. The important thing here is that my assert now is just a function, so users don't need to call a macro. We can get rid of that entirely, and we only have one time the name assert, which I think is pretty good. But coming back to the question. So the question from the user was, is it good to pass source location here by value as I do it, or by const reference? Remember what we looked up before in CPP reference or the standard itself. The note there says that the aim is to provide a very small source location object, but it's not required. And what is small after all, right? So small, the best small would be that it fits into a single register, because that would be great. But we technically have a pointer to a file name and a size t potentially for the line number. And since we can also have the function name, that might be another pointer. So squeezing that object into just a register seems very impossible, right? So here's my test code, and I also written a blog post about that. So if you prefer the written version, you can go and check out my blog. So here we have, let me increase the font size. Here we have a very small test. So I'm getting the size of a source location object and verifying that it's equal to the size of a void star, so a single pointer, and putting that all in a static assert to see what's happening. And then I'm using Compiler Explorer's awesome conformance view with GCC, Clang, and MSVC here. And what you can see is that GCC and Clang both pass the test, while MSVC at this point fails. Fails is a sort of fail because the standard totally allows them to make the object bigger. So what you can see here is the GCC and Clang, or more precisely the standard libraries backing them up, went out of their way together with the compiler to really squeeze you a source location object in a single register. They are doing this by having the compiler prepare a special structure that contains your line number, your file name, your function name, the column number, in theory at least, mostly it's 0, and hand out only a pointer to the library, because all the data is const, right? It's compile time, so they don't need to really pass it around. So the only thing the compiler hands to the standard library here is a pointer to this well-prepared object containing all the information. And with that trick, GCC's and Clang standard libraries together with their compiler make a source location object fit into a single register. MSVC went for a different implementation. I have no insight as to why they did that. Maybe it's because they are on a different ABI, a different platform, and it makes more sense for them to do it a traditional way. So they have a source location object that really contains all the parts and pointers or size t's to the individual data members. And this is why your MSVC compiler comes up with a larger source location object than Clang or GCC. Coming back to the original question, what does that mean for you? Well, it's tricky. In case you know that you're only developing for a target that uses GCC or Clang, let's say preferably with an Itanium ABI, then you can pass a source location object easily by value and have a very efficient and speedy code. If on the other hand you're either on Windows or you develop code that is targeting Linux and Windows, macOS potentially as well, but Windows here is the deal breaker, then you might be better off passing a source location object by const reference, because that would avoid copying a larger set of data or consuming more than a single register at this point. These are things as they are. I'm not sure whether MSVC has plans or will improve. From my perspective, it would be great if MSVC would align to the two other compilers and their implementation of the standard library, such that my advice could be simply, yes, you can always pass it by value, but we are not there, and they are still totally inside what's allowed from the ISO standard. You have to make the decision here, and if you want to stay on the safe side, you can say you always pass by const reference. That would be a good decision after all. I hope you enjoyed this episode, and I'm looking forward to your comments, your feedback on this episode. Maybe I'm doing more of these answering episodes in the future. That's it for today. Thanks for watching.